Here we are in section 2.1, where we're going to talk about slopes and rate of change. So a lot of this may seem like review, but make sure you look into for deeper meaning. Make sure you have really solid understanding and listen, because bits of calculus are going to slip in here as we go along. So the very first thing I want you to do is take a look at this set of data, analyze it, make sense of it, and then use this table of data to find the average rate of change for the runner's time over the following intervals. So note this is interval notation. So for the first problem here, we're going to find the average rate of change for the runner from 0 to 4.3 seconds, because it's their times over the intervals. So 0 to 4.3. So pause the video, try it if you know how to. If you don't, well, here I go. So how do we find average rate of change? Well, what does it mean? What does average rate of change mean? Well, if you remember, that's just hidden language for the concept of slope. Slope usually doesn't have a meaning to it. It's just x's and y's, where we tend to talk about average rate of change when we have something to reference, time, distance. So let's do this first one. So what is the slope formula? Well, that was y2 minus y1 over x2 minus x1. Now that drives me insane, because what is x? What is y? Input and output, right? So let's take a brief second and think about what would make sense. Which one of these would we want in the numerator? Which one would we want in the denominator? Think about how we typically talk about these units. If I did seconds over yards, what would that mean? We'd read that as seconds per yard. Do we usually read it that way, or do we usually read it as yards per second? Yeah, there's the winner, yards per second. So what we're going to do, we are going to do our slope formula, but it's going to be our, instead of y2 and y1, no. We're going to make it distance 2 and distance 1 over time 2 minus time 1. Okay, so our distances would be, let's go find that distance. The distance was 40 minus 0 over our time of 4.3 minus 0. So therefore, that simplifies down to 40 over 4.3, which is approximately, 9.3. Great. So now, if you needed help, there you go. There, I've done one for you. Now you try the next one. They're all done the same way. So now just make sure you can interpret the interval and try it again. And here we go. So for the next one, our slope would be distance 2 minus distance 1 over time 2 minus time 1, which would be distance, well, it's still 4.3, so it's still a distance of 40. But now at 1 second, instead of being at 0, we were at 3 yards. And then for our time, we're going from 4.3 seconds to 1 second. So therefore, that gives us 37 divided by 3.3, which should be approximately 11.2. All right, there's 2 of them. All right, now I'm just going to go ahead and pause the video and finish these all up. You do the same. Okay, so now I've gone in and filled in the other 3 answers. So double check your work, make sure you got them right. If you have any questions, always ask. So nonetheless, we now have our average rate of changes for all these intervals. Fantastic. Now, I will show you, well, in a minute we'll go back and take care of this, because the directions do mention being able to do it in your calculator. So we'll go ahead and make sure we know how to do that in just a minute. Okay, so right now, by hand, far more important. You can always revert to by hand. Your calculator sometimes fails you. All right, so here we go. Now, next most important part. Yay, math. We solved for numbers, completely meaningless numbers. That does no good in the real world. That does us no good right now. What we need is the meaning of each of these average rate of changes. So go back and ask yourself, what does 9.3 mean? Okay, think about the units. Think about what divided by what. What are we saying? Okay, pause the video, take a second, get down your thoughts, and here we go. So what does it mean when we do 9.3? Well, as we talked about before, it's distance over time. So the distance was 9.3. Well, here, if I back up just one little spot. Let me, whoops, that's not what I wanted to have happen. Let's try that one more time. If I just back up right here and say, okay, what we were looking at, the meaning of the 40 was it had the units of yards. The 0 had the units of yards as well, so therefore we're left with yards. In the denominator, it had the units of seconds. So what we really had here was the runner ran 40 yards per 4.3 seconds. So does that make sense? So from the time interval, going from 0 to 40 seconds. So they shot the gun, he started running, now 40 seconds has gone by. How far has he gone? Sorry, let's try again. They shot the gun, time 4.3 seconds went by. How far has he gone? 40 yards. There we go. So that, yeah, conceptually that makes sense. So here, that's what we're seeing, because from the time interval was from 0 to 4.3, so 4.3 seconds elapsed, we ran 40 yards. So the units, even though we divide it, the units don't change. This would just be like over 1. So what are we now saying? He ran, or she ran, 9.3 yards per 1 second, or a little nicer, 9.3 yards per second. So now, what kind of rate of change is that? Is that what they were doing? Is that their speed? Is that how fast they were going? No. That was their average rate of change, because the key word here being average, what we started with. So over the entire time, they ran an average of 9.3 yards per second. So why do we now see a different number here when we change the interval from 1 to 4.3? What does this mean? So instead of going 9.3 yards per second on average, they ran 11.2 yards per second. And then here we ran 13.04 yards per second. So I think you're noticing the trend. So go back and look at the other numbers and see what you notice. Okay. So now, when you describe the meaning of each of the average rate of change that you found, what you're going to say is something about that was their average speed over the interval. Something like that. Each of them would be the average speed. Average being the key word. Average is extremely important because we're going to have different kinds of rate of change in this class. So I'm trying to make sure you understand that what you've learned in the past is average rate of changes. All right, so now looking at those numbers, describe what conclusion you can come to when comparing your average rate of changes from above. So when you're going through this, stop and think about all right, what do you notice? What can you say about the runner? And all right, so now that you've done that, hopefully, let's go ahead and talk about it. So what I notice is when they're going from 0 to 4.3 seconds, that's the entire time of them running. If you think about it, when you start running, you're not moving, you're going very slow. Then as you run, you get faster and faster and faster as you get to your top speed. So what if we keep chopping off the first second, then chop off to the second, chop off to the third second? What we're doing is we're getting the runner as they had run and built up all that speed. So therefore their average speeds, we got rid of the slow ones, so we're getting left with fast ones. So what you'll notice is they're getting the average speeds are going up. So you can go ahead and fill in something like that in there. Okay, so hopefully that makes sense. And I would add on an extra question of saying, can you venture to what you think maybe the runner's top speed would be? Do you think they are approaching their maximum speed at 16.7 yards per second, or do you think they'll continue going up? Think about it. Just a challenging thought. Okay, so now let's talk about creating a regression model using your TI-83 or 84 calculator to describe the data above, and then draw a quick sketch of that model. So let's get out our calculators. Okay, so I hope this resolution is going to work for us. I think I got all the keys on the screen. So what we're going to do, we need our data. So I'm going to scroll up, get our data, scoot this off to the side as best I can. I'll have to move it back and forth. So if you don't remember how to do a regression, I'm going to try to do it slow enough that hopefully you can follow along, but there are plenty of videos out on YouTube that you can watch where you can see this. So what we're going to go ahead and do is we're going to press the stat button, because all of this regression stuff lives in the stats world, the statistics world. So once you're in here, you can see right now we have the option. We're in the screen here. It says Edit Calc Test. We're going to want to edit because the first thing you have to do is enter your information. Now you'll notice, I apologize, my button is not on the screen, my enter button. So what I'm going to do is just press enter in the bottom right hand corner, and it will bring up a list that says L1, L2, L3. Hopefully that is working for you. You got that. Now the next thing you need to do though is you might need to do is clear out information. You have data, you've got stuff in your calculator already. We got to get rid of it. So what we're going to do, we're going to arrow up to the top of the column that has our data in it. And instead of hitting delete, because if you hit delete, all it does is removes the L1. That doesn't do us any good. We want to clear the data. So you'll notice down here below the down arrow button, there's a button that says clear. We're going to go ahead and hit that. You'll notice the list of values here in the L1 has now disappeared. So we're going to go ahead and hit enter. Again, I apologize, it's off the screen. We're going to hit enter. And now all that data is gone. You could do the same thing if you had data in your L2, if you had numbers in there. You could go ahead and just arrow up, hit clear, hit enter, and it will clear it right out. Okay, so now we're ready to enter our data. Now your calculator has a default where L1 is X and L2 is Y, or aka L1 is your input variable, L2 is your dependent variable. So you can help yourself out a lot if you take a second and think about how you want your data represented before you start typing things in, because the order in which they're presented on your table or in your graph or however they gave it to you may not match what you want to do. So we already talked about it though. That was a nice thing. We already know our distances is our Y's and our times is our X's. So our L1 column will be our X's. Our L1 column will be our times. So we're going to go ahead and type in those numbers. And I do have a challenge where my 0 is not even available to me. Let me see if I can cheat it. Yes, I can. All right, so go ahead and type in 0, then 1 second, 2, and if this is off your screen, again, what we're doing, all I'm doing is just typing in the number that I want and then hitting enter. And then our last number here is 4.3. So we're going to do that. There we go. All right, so we got all of our times. So now our times go in the X. And again, if I go too fast on something like that, just pause the video so you can catch up. Okay, so what we're going to go ahead and do here now is go over and put in our Y values, or our distance values. So I'm going to pause the video and get those in. You do the same thing. These will just be our distances. Okay, so now we have all of our data in. So now we're ready to actually calculate the regression. So the first thing we need to do whenever calculating a regression is figure out what you're looking at. So what we're going to do is make a graph of this data to see what kind of regression model we should use. So I'm going to go ahead and press Y equals. Any old stuff, clear it out, get rid of it. We don't need it. So get rid of that. Get rid of that. Now, to look at data that we put into our statistics tables, we need to have the calculator plot them for us. Now, if nobody's goofed up your plots, if they're still in defaults, you see right up here it says plot 1. All we're going to do is arrow up, hit enter. Now our calculator will graph those values for us. If you would like to check your plots, what we're going to do is, do you see above the Y equals sign it says stat plot in blue writing? So we'll press second, Y equals, and now you see I turned on plot 1. And it's saying the defaults are L1 and L2. So I know those are the columns I put it in, so we're fine. But if they had the wrong values there, you could go into this by hitting enter. And now you'll see this is where you can change it. Your X list is the items in L1, your Y list is the items in L2, and you could go ahead and change that if you ever needed to, but I think it's always easiest just to make sure you type your stuff in the right L1 and L2 columns and all stays good. Okay, so now what we're going to go ahead and do. Oh, and if you want to, how it displays your points, you'd see this is where you change that. Right now, the default is little boxes, so it's going to display each of those points as a box. You can do it as plus signs, or you could do it as individual pixels. I highly recommend do not do individual pixels. They're very hard to see. That's why the boxes or plus signs are much better. Okay, so back to the Y equals. We have our plot turned on. So if I hit graph, I probably won't see very much. Because the window hasn't been set to our data. So what we're going to do is go ahead and press zoom up here in the top row, zoom, and we're going to look for something in here called zoom stat. Because the data we did was in the statistics area, there we go, it's number 9, zoom stat. So you could either get here by arrowing down and hitting enter, or you could just type in the number 9. So, and there we go. And do you see it automatically adjusts the window to fit what we're doing, to make it look, you know, appropriate for all of our data points. So let's go ahead and look at this. So does this look linear? And don't forget, don't miss, we got a point right there at 0, 0. So does this look linear to you? Quadratic, cubic, quartic, power, exponential functions? And so to me, I think it looks like a nice quadratic. We can give it a shot here and say, okay, it looks like it's going to kind of curve up and keep curving up to some extent. So let's go with a quadratic regression. Okay, so back to the calculator. What we'll do is we'll press, now that we know what kind of regression we want, we're going to press stat, arrow over to calculate, because now we want it to actually calculate something for us. You notice option 5 is quadratic regression. So we'll go ahead and arrow down to quadratic regression, or just type the number 5, hit enter. And on the new operating system, it gives you this list where we can say the X list was L1, the Y list was L2. Make sure there's nothing else there. And where we want it to store our regression, we're going to go ahead and type that in here. Now, for people with the old calculators, don't worry, pay attention to how I'm going to do this store regression equation, and then I'll go through and show you very quickly how you do yours. It's very not too bad, it's very easy. Okay, so for new operating system people, we have our x's in L1, we have our y's in L2, and when we get our function, we're going to want it to type it into the calculator for us. So we're going to press vars, because we want a y variable. I want it to be a y equals. It's a function. So now you'll notice here in the top side, to the right, it says y vars. I'm going to go ahead and arrow over to that. And we don't know what parametric equations or polar equations are, so let's just go with functions. All right, so hit enter or type the number 1. And now all it's asking you is in your y equals area of your calculator, do you want it in the first line, second line, third line, fourth line? We'll put it in the first line. So I'll leave it right there on y1. And you'll notice now it's going to do a quadratic regression using the values we typed in and take the answer and store it in y1 for us. So now I'm going to hit arrow down, hit calculate, and voila, there is our regression equation. Now note, if you've, well, and there you go. Note, it has filled it in for us into the y1 equation. And when you press graph, you'll see it's a pretty good fit. Okay, now for people with the old operating system, you're saying, what about me? What about me? All right, when you pressed your stat, calc, quadratic regression, your window did not jump to this, right? Instead, it looked something, whoops, let's try that one more time. It looked something like this. You just got on your screen the quadratic regression and a little blinky cursor there. Now, I think what you could see though was all the calculator did on the new operating system is filled this in for you. So to do it in the old operating system, you just have to fill it in yourself. Now, the good news is the calculator automatically defaults to L1 and L2. So if you just wanted to do the regression for you, just hit enter and there you go. If you want it to store for you, I believe, let's see if this works. I believe what we can do is do the yvars fun stuff, and I believe it will store it right there for you. Yes, absolutely. So for you, for the old operating system people, if you have your x1 and your x2 as your L1 and your L2 as your defaults, your calculator automatically assumes that. So all you need to do now is say, where do you want it stored? So again, that's the vars, arrow over to the y vars, hit enter, tell it which line you want it typed in, and now you have quadratic regression stored in y1, you hit enter, and voila, there you go. Okay, so everybody's now at the same place. So we've got our regression, we got equation, we've made our regression. So let's go ahead and for our notes, fill in our equation, fill in our regression equation. I already did a sketch because I just dragged and dropped it from my calculator. Lucky me. You kind of draw a sketch, and let's see what we do. Now, do you want to write your equation here using x and y? I argue no, 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 because that's not what we're talking about. We're talking about time and distance. So our output variable was distance and our input variable was time. So let's write our equation that way, our function that way. Our function would be the distance as a function of time. Where now, if you look back at your calculator, you'll see it was something about 1.84 t squared. Yes, your calculator says x squared because it doesn't know it was time, plus 1.41 t minus 0.0983. Great. So now we have a function that describes how our runner was moving with relationship to time. Okay. Now, using your model from the previous part, find the average rate of change for the following time intervals. So in the first part, we did all this by hand. We were able to do all this by hand. Now, this time I told you we were going to come back and make sure we know how to do it in the calculator. I'm going to show you how to do this in the calculator. So the nice thing, we've already have our equation typed into y1. So what I'm going to do is cheat a little bit. Our equation for finding average rate of change, we all hopefully remember, is slope, right? So it's y2 minus y1 over x2 minus x1, right? So in this case, we're going to just use a little bit of function notation. So remember, these are the times, the interval from 1 second to 2 seconds. So for my equation, I don't want an x value, I want a y value. And I want the y value evaluated at 2 seconds. The y value when the time was 2 seconds, minus the y value when my time was 1 second. Or, aka instead of y, we could switch it to d's, which would make a little more sense, saying I want the distance at 2 seconds minus the distance at 1 second divided by 2 minus 1. And that would be the equation I would use for this first average rate of change. So then the second average rate of change, what would change? Notice every single one of these problems is at 1 second, 1 second, 1 second, 1 second, 1 second. The only thing that's changing is the other time. So how do we represent things that change in mathematics? Well, we typically use x's, right? And this is going to be the key for getting our calculator to do this math for us. What we're about to type in is this exact equation. But again, your calculator doesn't know it's a d, so we're going to have to use y. All right. So where do we go from here? Well, and don't forget implied parentheses. Whenever you're doing an equation, you have things with numerator and denominator. There's parentheses around the numerator, parentheses around the denominator. Okay, so here we go. What I'm going to do is arrow down to my y2 line, put a parenthesis for my numerator, and I'm going to say, all right, I want the distance. How do I get that? Well, that's coming from my function up above. That's the function we created. So what we're going to do is press vars, arrow over to y vars, hit enter, and say, okay, where did we store our distance equation? We stored it in y1. So we go ahead and hit enter. Now, your calculator isn't quite sure what to do with it yet, but it actually does understand function notation. So what I can do is put parentheses around it and say, I want the y1 equation evaluated at some value, which I'll tell you later. It's a changing value. Minus. Now, that took care of the first part of our equation, right? That we just typed in this piece here. We still have to do the second piece. We still have to do this piece. So let's go ahead and do that. That would come from, again, it's another distance value. So we're going to go vars, arrow over to y vars, hit enter. It's a y1 value. And we're going to go ahead and put parentheses and say, now this value isn't changing. Every single time is evaluated at 1. So we're going to go ahead and fill in a 1 there. And the calculator is smart enough to know that's not 1 times y1. It's saying take 1 and substitute it into that equation. Great, that's our numerator. So I close my parentheses, and now I'm going to go ahead and divide by the denominator of x minus 1. Okay, so now that we have it typed in, it may have taken a little more work to get this all typed in into the calculator, but now the good news is it's going to do some heavy lifting for us. So what we're trying to find, since we're trying to find average rate of changes in this problem, I don't really care about my distances that I'm getting from my y1 equation. So what I'm going to do is arrow over to the equal sign, hit enter, and now when I do anything in the calculator, it's still going to use the y1 equation that I've referenced, but it's not going to graph it. It's not going to show it to me in tables. It's going to leave that out. It's just going to show me the y2 stuff. So now if you notice here in the top right hand corner of your calculator, there's an option called table. So I go second, graph, and that brings up a table of values. Now this is perfect. This is great because now this is showing me the answer. When I use this equation, it's showing me the answers of filling in when I fill in 2, 3, 4, 5 for x. Well, I don't want 2, 3, 4, 5, and whatever for x. I want 2, 1.1, 1.5, 1.1. So what we need to do is change the calculator so it will, we can type in our own values. And I personally like that much more than having the table autofill for me most of the time. So the table's great, but first thing we need to do is do table set right here above window. Do you see it in blue writing, table set? So if you go ahead and press that, the one change we need to make is right now in the independent variables, the variables you type in, instead of having it autofill, we're going to go ahead and arrow down, arrow over to ask, hit enter, and so now it's going to ask us for what we want. So go ahead and do that. Now what we're going to do is hit second, go back to the table where we were, and notice it's blank because it's waiting for us. It wants to know what values do you want? What x values are the values you're looking for? So for the first one, we wanted 2. So I'm going to go ahead and type in 2, hit enter, and you'll notice I now have an average rate of change of 6.94. So then for the next one, I'm going to type in 1.5. And I will go ahead and let you guys fill that in. I will put my answers in and we'll reconvene. So you will now notice that these answers are all done for us. So it took a little bit of extra setup to get there, and you have to know how to use the calculator a little bit, but now a lot less number crunching by hand. So we'll go ahead and fill these in, and then just like the last set of numbers, you probably will know what's coming next. Yay, right now these are just random numbers written on a page. What do we really want to know? What do they mean? What are they saying to me? So just like we did last time, I want you to go through and figure out the meaning of these. Think about units, and I'll give you a hint, they have the same units as before. So go ahead and give it a try, and when you're ready, unpause the video, see how you did. Okay, so same meaning as units before, so therefore these are still yards per second, right? Or yeah, yards per second. So if we look at the average speed of the runner, the average rate of change from 1 to 2 seconds, they were running at 6.94 yards per second. If we narrow that interval down to from 1 to 1.5 seconds, it's 6.02 seconds. So I'll let you guys fill that in. So follow the pattern. There you go. So now describe what conclusion you can come to from comparing the values above. Now this is important. You will notice something. There's something very different about how these numbers are progressing from A to E than how the previous problems were. The previous problem it had a kind of different goal in mind. Now this one, you'll notice the numbers, instead of getting further apart or anything like that, they're getting closer together. And in fact, they're getting really close together, like really close, like 0.001 seconds. I mean, that's like nothing. That's like going now to now, now to now. So, sorry, that's an inside joke. That's from a movie. Anyway, so nonetheless, and bonus points for anybody who knows what movie that's from. Okay, so here we go. 5.1 seconds, yards per second. What can we say when we compare these values? You notice they started at about 7 yards per second, then 6 yards, then 5.28, 5.12, 5.1. Do you notice they seem to be approaching a number? We had a big jump from the first number to the second number, then a smaller jump, then a smaller jump, then a smaller jump. So what can we say? Well, to me, how I would interpret this is it looks to me like our time is approaching essentially just 1 second. So instead of having a large span of time over 4.5 seconds, what was their average speed? Essentially, we're getting over a very, very, very infinitesimally small period of time. So essentially, it's kind of like if you're driving on the freeway and someone said to you, how fast are you going right now? Right? You would look at your speedometer and tell them. Now, could you really tell them that the instant how fast you were going, or would there be a little gap, how long it took your brain to process and whatnot? Well, yeah, of course there'd be a little gap. So that's what we're seeing here, is that little itty bitty gap. So if someone asked you, how fast was this runner going at exactly 1 second? This looks like a pretty good estimate. So what conclusion can we come to? I would say something like at 1 second, the runner was going about 5.1 yards per second. To me, that's what I would take away from this. And what we're noticing is the difference between that first set of data was an average rate of change. Here, yes, technically this is still an average rate of change, but is it really an average? Yeah, but is it really describing something at a moment? Well, because the time interval is so small, that's where we go to with this. That's where calculus is going to take us in this class. As we say, let that interval be so small you don't even know it's there. Okay. So now, using the sketch of the model from above, so here comes my crude sketch. Okay, think about that being 1 second, that being 2 seconds. What I want you to do is plot the points, and it doesn't have to be perfect, it doesn't even have to be close. The idea here is think about what's happening here. If you were to plot the points and connect the dots, what kind of line is that? Notice I want you to use a little bit of geometry. It's a secant or a tangent line. Well, if you don't remember, secant is a line that passes through a shape touching at 2 points. So we did a lot of circles in geometry, so you talk about secant lines being ones that pass through, and tangent lines being ones that just touch. That I totally missed, but the idea is a tangent line is where it touches only at 1 point. So this line here, when we go from 1 to 2 seconds, is a secant line. When we narrow that interval down to 1.5, once again, it's going to touch at 2 places. So it's a secant line. And as we move these points closer and closer together, let me see how far I can zoom in to really, as we move these points closer and closer together, you'll notice secant lines, they're all secant lines, but as it gets closer and closer, essentially it's becoming the same point. They're becoming so close, the distance between them is so small that that point was 0.001 apart, right? It's essentially going to start looking like a tangent line. And that's going to be the key as we go forward through this chapter. What are we doing? We're taking intervals that start far apart and sliding one point closer and closer and closer in until they become so close that they look like a tangent. It looks like 1 point. Okay. All right, let's finish this up. Now, a little bit of harder algebra for you. Using your model, the model from that we calculated way long ago, round your values to the nearest whole number. Okay, we normally wouldn't do this. I'm just doing it because otherwise the algebra is going to become really bad. Round your values to the nearest whole number. Okay, so what would that be? For me, that would be 2t squared plus 1t, or aka just t minus 0. Okay, because our original model was 1.84t squared plus 1.41t minus 0.0983. So rounding that to the nearest whole number, we get this. Okay. So now what I want you to do, not using your calculator, algebraically find the average rate of change. How do we find average rate of change? Yeah, that's slope. Good. Okay. So using that interval. But I will say, before we fill it in, some people may prefer, because we have a t value of 1 plus h, you may prefer to kind of do that algebra before you start filling it into the problem, where you just say, okay, this is 2 times 1 plus h quantity squared plus 1 plus h. And if you kind of work it to the side like this, sometimes you can avoid getting confused when you have it all filled in the formula. So here I'll go ahead and FOIL or distribute, whatever terminology you like. So that'd be 1 plus h plus h plus h squared plus 1 plus h. And then now I can go ahead and distribute my 2 to get all these like terms, to get everything simplified as possible, and then we can combine like terms. So that'll give me 2 plus, let's see, h plus h is 2h times 2 makes 4h plus 2h squared plus 1 plus h. So finally that gives us what? I'll put these in descending order. So that's 2h squared plus 5h plus 3. So therefore, now I have a simplified version of the function to substitute into my slope equation. So now, oh, and then the other one I just need my other y value of d of 1. So when I substitute that in, I get 2 times 1 squared plus, plus 1. So that makes what? That makes what? 2, 3. Okay. So therefore my y values, the slope would be y2, well actually let me do it the other way, it'll be a little easier. Y2 minus y1 all over x2 minus x1. So now if I simplify that, let's see, the 1 and the negative 1 subtract, and then my 3 and my negative 3, those subtract, leaving me with 2h squared plus 5h divided by h. And now this is an awesome moment because you'll notice I have h's in my numerator and every term in my numerator and h in the denominator, so I can now factor. And that's going to make me super happy because I can factor out my h, which is going to leave me with 2h plus 5 divided by h. Those h's divide, leaving me with the slope of m equals 2h plus 5. And there we go. So hopefully that algebra wasn't too tough to get through, but now we have a pretty neat moment because we now have our slope, a function for our slope, where we now have it described where the h is the distance between the x value of 1 and the x value of 1 plus h. So I can now use that to get me through this next step. So let's go ahead and use it down here. So let's go ahead and say, okay, so what we're saying here is, what if h were 1? Okay, what does that mean? Well, back at the previous, we had the x interval of going from 1 to 1 plus h. So therefore, we have d of 1, or we'd be going from 1 to 1 plus 1. That's where if h were equal to 1. So what we're talking about is the interval of going from 1 to 2. Right? We had to change, h is a change in how far apart our x values are, or t values are in this case, and they're 1 apart. So if h was 0.5, then our interval would be going from 1 to 1 plus 0.5, which would be the same thing as 1 to 1.5. So I think you're getting the idea here. Now, you'll notice if you stop and think, this is very similar to what we were doing back before, but now, instead of having to do 1,000 slope equations, we've already got our answer right here. The slope is 2h plus 5. So for this first one, the slope here, instead of going through and actually finding this interval and doing all the work, I just substitute in 1. So therefore the slope of this would be 2 times 1 plus 5, so therefore my slope would be 7. So therefore I know the average rate of change going from the x value of 1 to 2 is 7. Similarly, here, same idea here. If I want the average rate of change from 1 to 1.5, well, okay, what's my h? Well, that h is 0.5. So, excuse me, I forgot my plus 5 there. There we go. So therefore, what is 2 times a half, or 1 half of 2? 1. 1 plus 5 makes 6. So therefore, the average rate of change of the x values going from 1 to 1.5 is 6. And you could go and do this exact same problem the old-fashioned way and verify that these numbers give you the same numbers. We just don't need to do all the different slope formulas anymore. We can just take our h values and sub them into our slope equation. All right, so now, summarize, big ideas. don't lose sight of the point of this whole section. What did we go over? And I apologize, I went in here and had to correct some notes, so you'll see they're not filled in. So your job, go back, look through your notes, and try to get the big idea. But I will say the thing I want you to focus on is the thing you should be mentioning down here is instantaneous rate of change versus average rate of change. Okay, make sure you are addressing that. What do those things look like? What are they? Are they slopes on tangent line, or slopes, tangent lines, secant lines? How are they calculated? Well, right now the instantaneous rate of change, we're working our way there, but we've conceptually gotten there. So just make sure that you're putting together those big ideas. Okay, best of luck.